Okay, let us discuss easy problem first and then we'll discuss more. So this problem is from rotation. So this problem is from rotation. Easy problem. This says, so let me first make the diagram and then we'll discuss the problem. So you have somewhere here and then it goes this. And then let us first make the diagram and then we'll discuss the problem. So this is center. Now we have r by 2. This means this becomes something like this. So this is the circle, same line. Okay, so what the problem says, so let me write, this is r, this is r by 2, this is also r by 2, of course this is r by 2, and any other point. So this problem says there is a carpet of mass m made up of inextensible material. So the mass of carpet is m, so there is a carpet of mass m, inextensible material, so it cannot be extended, so this is unstretchable material, round along its length in the form of a cylinder of radius r and kept on a rough floor. So this is, so carpet is rolled and it forms a radius r. So carpet is rolled in a form of radius r. Carpets are frictionless, but the surface and carpet has friction. So this friction, due to this friction, this rolls. So this, let us say this carpet is rolling in this way. This means unwinding the carpet. So carpet will roll here, and finally the length of the width of the carpet will decrease. So thickness of carpet will decrease, radius will decrease. Initially the radius is r. So some of the carpet is lying down on the ground. So rest of the carpet is banded. So this is unbanded part. So this is unbanded carpet. Unbanded carpet. And this is a banded carpet. So you see, in this case we have to find. So let us say what the problem says. The carpet starts unrolling without sliding on the floor when the negligible a small push is given to it. So there is a very small push is given to the carpet. So we have applied a small push to the carpet so that it can start unbinding. So there is a small push that is given to the carpet, and due to this a small push, this starts unbinding. So let me write here. So a small push is given. A small push is given, and this push is basically able to unbinding. Now we have to calculate the horizontal velocity of the axis of cylinder. So we have to find horizontal velocity. Horizontal velocity. What is the horizontal velocity of axis of cylinder? So this is an important point. So axis of cylinder is this. So we have to find axis of cylinder when the radius reduces to r by 2. So we have to find this when radius becomes r by 2. So radius is r by 2. Now the important point is, let us try to understand why this is happening. This is happening because the rolling motion of carpet is due to the lowering of the center of mass of carpet. So you see, center of mass of carpet is initially here. Now center of mass is here. So there is a loss in potential energy, and that's why there is a gain in kinetic energy. So the main point is loss in potential energy of carpet is equals to gain in kinetic energy. So gain in kinetic energy. Gain in kinetic energy. So we have to basically find loss in potential energy equate gain in kinetic energy. So initial potential energy, I can say loss. Let us find first loss. Initial potential energy is mgr. If this is my datum, so mgr is the initial potential energy. Final potential energy is now m dash g r by 2. Now we have to find m dash. Now I can clearly say mass is proportional to length with this pi r square into length of the carpet, that is L. So I can say m is equals to pi r square into L. M dash is equals to pi r by 2 whole square into L. So m by m dash is equals to r square by r square by 8 as a 4. So 4. So we can say m dash is nothing but m by 4. So now I know new mass of the carpet is nothing but m by 4. So let us put this value here. So if I put this value here, I can say loss is mgr minus m by 4 gr by 2. So this becomes 1 by 8, so 7 by 8 mgr. So this is loss in potential energy, that is 7 by 8 mgr. Let us say gain. So gain in kinetic energy is half I omega square plus half m b square. So this is the center of mass. So let us say half m is nothing but m by 4. Initial velocity is 0. M is m by 4. V is v square plus half I is ml square by, so this is a solid cylinder, ml square by 2. M is m by 4. L is mr square, so r is r by 2. mr square by 2. So this is my I. Can you check this again? Half m r square by 2. So m is m by 4, r is r by 2, mr square by 2. So this is I. Half I omega square. Omega is v by r because this is a case of pure rolling. V by r is r by 2, half mv square. So if I take everything common, this is 1 by 8 plus. So if I take mv square common, so the result will be 1 by 8 plus. Now here what is the value? 4, 16 and 2. So 16 and 2, 32 and 2, 32, 4 and 4, 16, 32, 32, 64, but 60, so 16. So 2, 4 will go, 4 will go up, so 16. So I think this will come out to be 16, 2 plus 1 mb square. So this value is nothing but 3 by 16 mb square. Check yourself whether are you getting or not 3 by 16 mb square. Let me check the answer they are getting or not. So yes, they are also getting 3 by 16 mb square. So let me check, let me equate this. Loss is equals to gain. So loss in potential energy equals to gain in kinetic energy. So gain in kinetic energy, loss in potential energy, both should be same. And we have already calculated loss in potential energy is nothing but, so here this is 7 by 8 mgr. So this value, you see, this value is 7 by 8 mgr. And gain is, so I can write 7 by 8 mgr. This value is equals to gain is how much? So let us say 3 by 16 mb square. So this is 3 by 16 mb square. Now cancels out. So V is nothing but 8 into 2, so 14 by 3. So 8, V is nothing but, so you see here. So this V is 14 by 3, and now GR. So if I take under root, so this is 14 by 3 under root G by. So you see this problem, the important point is why this carpet is rolling. So the important part is, if I push this carpet with a gentle push, initially there is no velocity. If I push it gently, it will not get a velocity. This means gentle push will unwind this carpet. So carpet starts unwinding, and there is a friction between carpet and this surface. So it can go smooth rolling, pure rolling. So carpet just get on the surface smoothly, it goes on rolling. And the width of this carpet or radius of the carpet get decreasing because some parts gets on the floor. So there is a loss in potential energy because center of mass initially it here, after some time it is here, after some time it is here, after some time it is here. So center of mass gets decreasing. So there is a loss in potential energy, but there is a gain in kinetic energy because carpets gets some velocity. Use the maximum velocity of carpet will happen when the whole carpet is unwinded. This is an important point. Okay, we'll discuss next.